One way of representing a game is through what's called the extensive form. What is an extensive form? An extensive form can be represented as a tree. So you start with a node. So a tree is basically a graph which doesn't have any cycles in it. So you start with the initial node of the tree, and you have edges from that node. Now, in an extensive form game, each node is going to be labeled by the player whose turn it is to play. So, for instance, it might be player one who plays at the initial node, so we label it by player one's name. Each of the branches from that node would be labeled by the action, a different action that player one could take. So, for example, if there were 3 different actions player one could take at the very initial node, we might label them, let's say, A, B, and C. Now, after player one takes an action, that brings us to 3 separate new nodes. And now, at each of these new nodes, there's another agent whose turn it is to play. So we, again, label each of these by the name of the player who is going to play, who has to pick an action. So maybe when one picks action A, 2 goes next. 2 also goes if he picks B. Perhaps 3 goes after 1 if 1 picks C. Again, we keep repeating this process. Maybe the game, so that's one example of what might happen next. Maybe here we have 2 actions. Maybe here we have 2 actions. So we could write down, again, we're going to label each of these actions by, each of these branches by an action. So D and E, F, G, H, J. Now I still have to put in who moves here. Maybe this is player 2. Maybe there's a player 4 who goes at this node. So this is one example of a tree. So what we've done so far is to tell you who are all the players. So this representation gives you a list of all the players. So that's the first part of a game. It tells you all the actions that they could take. So player 1 could take actions A, B, or C. Player 2 at this node can take, so at this node here, player 2 can take actions D or E. At this node, player 2 can only take action F. At this node, player 2 can take actions I or J, and so forth. So what I've drawn so far gives us the first 2 parts of what a game needs to be described. I'll wait to tell you about information, so we'll skip over that. The fourth thing we need is the outcomes and how they're related to the actions that the players choose. So let's say we use capital letters to represent the outcomes. There's going to be one outcome here, another outcome here, here. So each of these, what we call terminal nodes, so these, if you think of this as a tree, then the ends of the tree, so which are either leaves or terminal nodes of the graph, so the points which there's no further edges out of that node. So we call that terminal nodes, and those are ones that we're going to associate each of those, rather than labeling them by a player, we're going to label them by an outcome. So A, B, C, D, E, F, and G are the different outcomes that could happen in this game. This representation tells us exactly how the actions taken by the players relate to or map to the outcomes. So if player 1 chooses A and player 2 chooses D, then we're going to get outcome A. On the other hand, if player 1 chooses C, player 3 chooses H, and player 4 chooses K, then we're going to get outcome F. So in this way, the tree gives us exactly the relationship between the outcomes and the actions that the players choose. But what we really need is the fifth component. What are the preferences of the players over these outcomes? What we're typically going to do is to represent those by the utility that each player gets from the different outcomes. So for example, you might have a table that says A, B, C, D, E, F, G, players 1, 2, 3, and 4. You'd write down the monetary value that each player gets from each of the possible outcomes. So for example, player 1 might get 10 from outcome A, player 2 gets 5, player 3 gets 11, and player 4 gets 2. So here, instead of A, we would normally just write, rather than A, we would just replace it with this vector of payoffs. And we call these payoffs. So we would write here 10, 5, 11, and 2. So this is player 1's payoff, player 2's payoff, player 3's payoff, and player 4's payoff. So typically what we're going to do is to actually, rather than write down what the outcomes are, we will just write down the terminal, instead of at the terminal nodes, we'll write down the payoffs instead. So instead of B, C, D, E, F, and G, we would write down the payoffs that they get. So whatever the payoffs are, we write them down here. And so that's what we call an extensive form. Now I skipped over the notion of information. So how do we represent information here? In this particular game that I drew, each player has sort of trivial information. Each player knows exactly where they are in this tree, and they know that when they make that decision. So player 2 can differentiate between making a decision here, and they know that their choices are D and E, versus here, where their choices are I and J. To illustrate the idea of information, let's look at a slightly simpler game with a more complex informational structure. So let's suppose we just had players 1 and 2. So player 1 chooses between action A and action B. And then player 2 gets to move next. Now, if we just did the kind of thing we had in the previous game, then player 2 here versus player 2 here, C and D, he'd choose between C and D here, E and F here perhaps. Now this player can tell the difference between these two nodes. What if instead we said, listen, this player actually can't tell which of these two nodes he's at. So these two nodes, from player 2's perspective, he just knows he's at one of these two nodes. And at each of these two nodes, he would then have to have exactly the same set of options that he could choose from. So his actions are exactly the same at these two nodes, and he can't distinguish between them. So in this game, player 1 moves first, and player 2 moves second. But unlike the previous game, player 2 does not know where he is. He doesn't know whether he's here or here. The interpretation here is that player 2 does not know whether player 1 chose A or B. All he knows is that it's his turn to move, and he has to choose either C or D. But he doesn't know whether he's choosing C or D from here or C or D from here. So the information that he has is simply that it's his turn to move, and not whether what player 1 had chosen. We call this an information set. So this is a set of decision nodes. They all have the same player. And because they have the same player, and the player cannot distinguish between them, he can't have different actions at them. So if at one of the nodes I have actions A and B, and the other node I have, let's say C, D, and E, well, clearly those aren't the same node. So they have to have the same actions. That's what we call an information set. So these information sets tell us all we need to know about the information available to the players at each point where they have to make a decision. So each decision node, so every decision node is in some information set. It could be that it's in a singleton. So for example, one's node here is an information set, but that node is in an information set all by itself. It's the only node in that information set. Whereas this information set containing these two nodes for player two contains two different nodes. But every node is in some information set. And that's how we characterize the information that the players have available to them. So this just about sums up all the various features of an extensive form. I'd encourage you to look at chapter 2 in the book, where the author goes through a nice story that he builds to come up with a particular extensive form. So he describes how he comes up with this particular extensive form based on a story involving Jeffrey Katzenberg, who's represented by K, and Michael Eisner, who's represented by E. So check out chapter 2 of the book. To wrap up this discussion of what an extensive form is, I want to just touch on a couple of additional points. So have a look at this game here, this extensive form game that shows up towards the end of chapter 2. Here you've got the nodes labeled by the players. Now, the convention normally is that we're going to label the players, we're going to name the players player 1, 2, 3, and so forth. So we're going to number them. So a convention that I want you to remember is that when we write down the payoffs or the utilities, we're going to start with utility of player 1, utility of player 2, and if there are more players, then we're going to do utility of player 3, and so forth. So the first number is going to be the utility of player 1, the second number is going to be utility of player 2. Sometimes we might draw the tree the way I drew it on the previous page, where I'd write them from top down. Again, we're always going to, the first one is going to be, the top one is going to be the player 1, and we're going to go down player 2, player 3, player 4, and so forth. So that's one thing I want you to keep in mind. The next thing I want you to keep in mind is that, or I want you to notice here, is that player 2 can choose between H and L. This H and this H are labeled differently. It's H and H prime. Why do we make the distinction? It's because player 2 knows the difference between this node and this node. They're not the same information set. So we want to be able to say player 2 chooses action H and know exactly what we're talking about. So if we say player 2 chose action H, then we know that he should have been at this node. If I say player 2 chose action H prime, then I know that he had to be at this node. So by labeling the actions at different information sets differently, it helps us distinguish between the actions that the player is taking. After all, taking the high action, which H represents, after the first player has chosen H, is different from choosing the high action after the first player has chosen L, if player 2 knows what player 1 has done. You can compare this with a very closely related game where player 2 doesn't know what player 1 has done. So here, player 2 does not know whether he is following player 1 after 1 has played H, or if he's following 1 after 1 has played L. The two choices he has are H and L, no matter whether he's at this node or at this node. And that's why we would not distinguish between the actions that he has available to him. Now, this particular game represents shows us something a little bit subtle about the timing of the game. Notice here I've been saying that player two is moving after player one. Here, this particular game allows us to look at situations where player two might be moving at the same time as player one. So saying that player two doesn't know what player one has done is equivalent to just saying, well, player two could be moving at the same time as player one. So that's an important feature about extensive form games, is that while they look like they have time built into them, that players are moving sequentially, they don't necessarily have to be moving sequentially. It could be that player two is moving at the same time as player one. So player two has to choose between H and L at exactly the same time as player one is choosing between H and L, even though we represent it in a way that looks like he's following player one.